All right. I think we're live. Are we live? All righty. Okay. Welcome everybody to EthVan here. Another edition on Thursdays. We're still on Thursdays, which is great. I think we'll keep with that for a while until, if in case things change upstairs. But good to see everybody again. Hello to everybody out online as well. Yeah, I think we've got one kind of like notable announcement here is we've been having like our, I guess like a donation round that's been going on giveth.com or giveth.io. Anyways, Giveth is a great platform to for donations and whatnot. And they currently have a $100,000 matching round. So among all of the projects that are eligible, they get, we'll split 100K. So thankfully, we've been pretty fortunate here from a number of donors from, I guess, throughout the audience and online as well. So thank you to everybody that's been helping trying to keep things running here. And yeah, to be able to get matching as well is pretty cool. So got a matching of, I think we're at 7,000 USD matching. So pretty stoked about that. So just a shout out and a thank you to everybody for that. And that page will stay up in perpetuity as well. So we'll be, eligible for any other future rounds and we'll be able to stay there. So that's pretty sweet. So thanks everybody for that. And yeah, as far as other events that we have, so Mondays we still have like the open mic night. So if anybody's interested in that, and then have we got? What am I missing here? Is there something next week? Oh, we were talking about like this Polkadot thing is coming up soon. I can't remember if that's going to be in a couple of weeks or not. But anyway, stay tuned on that. But next week we are thinking about doing a field trip. So we may not be here next week because the mayor is speaking. So Ken Sim will be at the BTC Van event. So we're maybe going to advise, it's a pretty notable kind of conversation for us to be a part of. I think it'd be pretty cool to, support there as well, as much as we love our Bitcoin friends. So that's kind of a thought for us for next week. So next Thursday, and I think that's at Funk Coffee Bar, which isn't far away, just by Bentall Station. So like 5 blocks, 6 blocks, whatever it is. So yeah, we'll keep you posted on that, but I think that's kind of what we're planning as of now to go and do that. So, all right. Yeah, we're going to do native rollups. We're going to learn about why they're way more better and how they're going to save Ethereum, right? All right, I'll let you take it away.
Thank you, Tangle. Okay, hello everyone. Thanks for coming. I'm going to talk about native rollups. The reason I'm going to talk about this topic is recently Justin Drake, the chief wizard of Ethereum, came up with this post on ETH Research that kind of lays out the idea of native rollups as a way to export the superpower of execution layer of L1 to rollups, and I'm going to explain what that means. It's a topic that's been discussed for a very long time. Maybe the first time I heard about the topic was 2-3 years ago when somebody shared the HackMD by Vitalik that was wrote in 2020 about this idea of native rollups. And people were kind of playing around with this idea for a very long time. But for many reasons, it felt impractical and kind of impossible. But more recently, it's becoming more practical. One of the reasons is you will see in details snarkifying Ethereum or proving Ethereum blocks in a short period of time, like in 10 seconds, 20 seconds, is now practical. But a few years ago, it was completely nonsense if somebody would have said that's possible. Aside from that, we didn't have the data availability available to us, but now we have, and for all those reasons and a few small other things that people have figured out, it may be a good time now to consider this proposal. So I'm going to explain what's native rollup and what's the promise, why it's significant, and then talk about why it's not so good and there are some challenges and that we need to figure out, and maybe it's not going to be something that every rollup adopts. So let's see how it goes. So first of all, we probably agree that Ethereum is secure. But why is that? Ethereum is secure because its protocol is battle tested. It was launched many years ago. And many of the core components have been around for many long time. If there was a fundamental issue in the protocol, it was exploited a long time ago. It secures a lot of money. So if you find a bug that can be exploited, you could gain a lot. So people have looked closely, right? Aside from that, we have client diversity because like there is this protocol, this theoretical thing that gets implemented into software. And maybe the protocol doesn't have any bug, but the software implementation has a bug, right? But like we have client diversity, we have all these teams, execution clients, many of them, like 5, 6 major execution clients, 5, 6 major consensus clients. They are implemented with different software stack, different like languages, different compilers, like totally independent, it seems. So if there's a bug in, say, let's say Prism, it doesn't immediately imply that there is a bug in all other clients as well. So we have kind of protection through client diversity. If one of the clients somehow is buggy, and the rest of them can continue working and the protocol carries on. Aside from that, the social layer of Ethereum is very resilient. Like the fact that a random group of people came together, we are not paid to do this, we are just interested, right? And we are now talking about a proposal that was proposed like a few weeks ago in ETH Research in the deepest research niche of Ethereum. And it's interesting to some of us. And all around the world, people are interested about this stuff, and they look into this stuff. So many eyeballs are looking at things and like are thinking about the well-being of the protocol. So it has a very resilient social layer. If anything go wrong, like the social layer somehow fixes it really soon, or at least we could trust that's the case. And finally, the development mechanism, the core development mechanism of Ethereum is very rigorous. Like things have to be proposed as EIPs, and then they get debated for months and months, and they get spec'd out, they get tested, there are test nets, there are like independent groups, and like something that gets implemented in the protocol is really, really audited and understood. So all in all, Ethereum is secure, and we have a strong reasons that its governance keeps it secure, like as it evolves as well. Okay. Now, the question is, are rollups really as secure as L1? So rollups utilize two things to inherit security of L1, right? One of them is data availability. They post all of their transaction data to Ethereum, okay? And that's helpful because we have consensus on L1. If your transaction data is on L1 and there is consensus on L1 about, okay, what's your transaction data, anyone can download those transaction data and execute them in your rollup execution client and see what's the state of your rollup, right? Some people say that DA is where you get security for the rollup. The proof system is not even needed. Security of the rollup, security of execution on rollup just comes directly from DA. The fact that you know what are the set of transactions and what is their order is enough for you to execute it in your execution client. You get something called offline finality, OP people call it that way. So we have DA and we have consensus on DA, and that gives us security. And also, in order to bridge asset to rollup and back, and bridge state to rollup and back, you deposit your USDC in a Scroll or Base or Arbitrum or whatever. The bridge of the rollup is a trust minimized bridge. And how is that possible? By a proof system. Because rollups need to prove all their state transitions. Everything that happens on the rollup is somehow proved to a smart contract on Ethereum. And if that smart contract is convinced that you're eligible to withdraw some amount of money, you withdraw. And if that's not convinced that you're eligible to withdraw, you don't withdraw. That's how I trust that nobody is able to take my money out of a Scroll bridge, because there is a ZK proof that shows the state transition. Assuming that ZK proof is sound and complete, I shouldn't worry. So what I want to emphasize here is the key part about the proof system and inheriting security of L1 is ensuring that these state transitions in L1, when you execute a batch of transactions of the rollup, say we had 10 blocks in a Scroll, and the Scroll prover wants to prove all of them to the smart contract on L1. You submit a proof, or like a scroll sequencer submits a proof that shows, OK, we were at this pre-state. This was the state of affairs on a scroll. Now this is the new state, and this is the result of executing these transactions that were posted to the DA, right? But this assumption of like assuming the proof system is sound and complete is a big assumption. Like sound means you can't prove fake or false stuff. And complete means you can always prove like all things that really happen, right? This assumption is really big, and I'm going to argue why that's a big assumption. Like first of all, it should be obvious. It took us years and years to build this proof system. Arbitrum, Optimism, they started years ago, right? And they were not even building ZK. They were building optimistic proofs, which are supposedly simpler to build. Like they don't need new cryptography, at least. And they had like fundings, they had everything, and it took them years to build it. Like just recently, Arbitrum went permissionless, like maybe like a few days ago. So it just shows how complex it is to build these softwares. And the ZK ones especially are based on new cryptography. We invented new cryptography to do that, basically. And they are not nearly as audited as Ethereum. We talked about like the social layer of Ethereum, but that's not like, Rollups have social layer, but it's not nearly the same level as like Ethereum, right? And usually all these rollups that we're talking about, they just have one proof system. Remember, for Ethereum, we have like this client diversity. Even if the protocol is correct, there could be a bug in one of the clients, but because we have diversity of clients, it's not that big of a deal. But for rollups with a single proof system and one single implementation, there could be a bug in every part of the stack. It could be in the proof system. It could be in the underlying cryptography. It could be in the implementation. Like, it's really a lot of surface without any redundancy. Now, there are some solutions for these problems. Like, for instance, there is this idea of multi-prover. You have ZK proof, like slap a TEE proof on it as well, or like use two different like independent ZK proof system or ideas like that. And some rollups are doing that. But without like redundancy, it's almost guaranteed that we have serious bugs in this system. Like, it's not a matter of if there is a bug in Arbitrum, a scroll, or OP. It's certain. Like, we definitely have bugs that are not discovered. Now, I'm not saying that somebody is going to exploit it. Like it's a bad guy is going to take your money. That's very unlikely for the reasons that we are going to cover in a bit. But the fact that there are bugs there is almost guaranteed. Now, if you think about it, upgrades are going to make things worse, because like not only these rollups implement like proof systems for state transitions of the EVM or something like EVM, they also do a lot of upgrades because EVM is evolving, new EIP is being implemented. Also, rollups come up with their nice, interesting ideas, like Arbitrum has a stylus, right? It's something new. They add it to the system and they upgrade it. And like some rollups have like certain precompiles that are not in Ethereum. Like Scroll has some precompiles that's not included in Ethereum yet. So they also modify their like execution environment as the time goes by and implement more and more things, and it just increases the surface for vulnerabilities, right? And that's the reason why we have rollups with multisigs. You might have heard that rollups are not really secure because they're just multisigs. There are like these 5 or 10 wallets that control the bridge. If they collude, they can take all the funds out. And the justification is, OK, there might be bugs. And because there are bugs, we should put some people in charge that like stop the rollup or take the funds out in case of an emergency. But this is not nearly Ethereum level security, right? And multisig is considered bad practice. But instead of that, we have governance and security councils, right? Like even most major rollups, they have like something called the Security Council, which is basically a group of experts that have the ability to halt rollup in a case of emergency or approve any upgrades or stuff like that. And we also have governance, like so that like there are checks in place if there's a bug or something goes wrong. But like we don't have similar things for Ethereum, right? Like we don't need a governance or security council for Ethereum in the sense that like whatever is implemented as and is in the protocol is there. Like it's fundamentally different to fork Ethereum than to like invoke a security council and pause a smart contract, like, right? It requires fundamentally different level of like social coordination. Okay, so back to the initial question, are rollups as secure as EthVan? The answer is not really. And the idea of native rollup is to somehow fixing this situation. And you could think about native rollups as like taking this rollup-centric roadmap of Ethereum one step further, taking some of the stuff away from rollups operator plate and like putting on Ethereum core dev like plate. Like they kind of take the burden for the rollups, right? And what's that? So the idea is we can introduce a new opcode to Ethereum called the execute opcode. And it takes 3 inputs. It takes a pre-state root of an EVM instance, right? Like you may have like your rollup, and your rollup is like running some EVM, like is an EVM compatible rollup. So in each state transition of the rollup, like currently when say a scroll proofs submits proofs, what it does is it's finalizing some state transitions, and each state transition is a statement like this. There was a pre-state. The state of the rollup was something. And now it's in a new state. And this transition is result of executing a list of transactions, right? So the idea is we introduce a precompile that takes these inputs and checks whether they are valid. Like it returns true if the transactions included. If you really execute from the pre-state, you get to the post-state, something like that. So to put it in a sentence, it's a stateless execution of EVM inside EVM. It's a precompile that lets you verify statelessly execution of another EVM instance. Okay, does it make sense? Now I wrote like transaction batch and a state witness. Like typically, you just have transaction batch. What is this state witness? That goes back to the stateless part of the story. So if you think about it, the rollups are supposed to adopt this, are supposed to use this precompile instead of having their own proof system. Okay? That means they don't have to maintain their own proof system. They don't need to implement their own proof system. When upgrades happen on EVM, they just get it for free. So those are the good parts. But the bad part is if all Ethereum nodes need to keep a state of all rollups, then things become like meaningless. Like that means any new rollup means more data to store for Ethereum nodes, and that's not clearly scalable. Like if we were going to do that, like we would just scale Ethereum itself. Why the heck we need rollups, right? So we need to do this in a stateless way. Otherwise, it becomes pointless, right? And just to remind you, you might have heard of this like stateful versus stateless clients in Ethereum world. Like a stateful client for Ethereum is a client that stores all the state of the Ethereum. It knows the state of all smart contracts, all accounts, knows everybody's balance, knows the value of every variable in every contract, right? And if you give it a block of transactions, it can execute that block or verify the correct execution of that block, okay? In contrast, there is another like type of nodes called the stateless clients. Stateless clients don't store all this information about Ethereum. They just know the state root, like a commitment to the whole state of the Ethereum. And if you give them a block of transactions, they can't execute it or verify its correctness. They need you to give some witness data. And that's like a storage proofs for every storage slot you access. Like every transaction you look at, for instance, it might be a transaction Mo is sending 2 ETH to Owen. So that transaction, in order to verify, you need to first check how much Mo has in balance, right? And then check whether after execution of the transaction in the post state, Owen's balance is increased correctly and Mo's balance is decreased correctly, stuff like that. And because the stateless clients only have a commitment to the whole thing, they need like this witness data, this Merkle path proofs for each step. So they need some additional data, additional witness, as it's called, to execute blocks or verify correct execution of the blocks. And this is the same thing here. Like now we're not talking about Ethereum blocks. We're talking about the blocks or like a collection of blocks for rollups. But because rollups are all like EVM compatible or EVM equivalent nowadays, it's kind of the same thing, right? Okay, I hope it makes sense. If not, like, feel free to stop me. So far, the idea is for any rollup, at the time of finalization, the rollup sends the pre-state, the post-state, and the list of transactions, and the necessary state witness. And every Ethereum client re-executes or verifies the execution of that batch for the rollup and returns true. This way, rollups don't have to implement their own proof system, and we don't need security councils anymore because there can't be a bug in their proof system. Yay. The problem of what I described is re-execution. Like in what I described, all Ethereum clients need to re-execute every state transition of every rollup, right? And like that's nice and totally feasible because like Ethereum nodes actually do have the capacity to do like a lot of these things. Like if you run a Ethereum node, you look up your CPU usage. It's rarely above 5%, even with like stupid CPUs. Even if you have a Raspberry Pi or something, it rarely goes above 30%, something like that. And the reason is running an Ethereum node is not CPU heavy. And like doing these re-executions, it's just a CPU intensive tasks. Because like it's stateless, you're not fetching anything from memory, you're not writing anything to the memory, you're just checking some stuff in your CPU, right? So there is actually a capacity to just do re-execution, and it works. But it's limited, right? Maybe 10 rollups can use it, or like 20 rollups. It's limited. The idea is we can do a lot more with snarkification. If nodes could just verify a proof for every invocation of execute precompile rather than doing the whole re-execution, that would be nice, right? That could be a lot more efficient. And the idea is we actually can do that. Like think about any block in Ethereum, block N, right? It may include some invocation of this execute precompile. And at first, it doesn't have any proof included. The first validator, or one of the first validators that hear about this block is Bob's validator. Bob is like a rich guy. He has like a lot of GPUs at his disposal. And for whatever reason, he likes to help Ethereum network. He can generate proofs and attach it to the block, and now propagate the new block with the proofs. And many other validators, like Alice's validator, which are like on small computers on Raspberry Pis, they don't need to re-execute the whole thing. They just verify the proof. So it could be done if like block proposers or some other like validators take on the burden of generating the proofs.
So sorry, I maybe should have asked this on the last slide, or the one with the execute function. So I get that like you have the pre-state, the post-state, and then you have some extra witness data. What is the proof system behind this? Is this like some proof system that's built into Ethereum that everybody uses the exact same proof system, or like how does this? What's on the back end of this precompile?
Very good question. Step one that I'm describing here doesn't have any proof system. It's just naive re-execution, right? Okay. So here we just have re-execution. The idea of proofs come as like some sort of optimization for execution environments, like for execution clients. Every execution client, for instance, Geth, can adopt like its own proof system of choice. And Nethermind can adopt like another proof system maybe. And the same way we have client diversity in Ethereum, they have different like programming stack, and like one is .NET, one is Rust based, one is like C++ or whatever. They can choose like different proof systems. And like that's kind of getting prover diversity for free because or multi-prover kind of built in this system. It's kind of, I think of it as some sort of optimization at execution client level, right? So they can choose different way of optimizing it.
Yeah. Okay, I think I get it. Can you go back to the other one? So, I mean, there may be more to this yet. I might be skipping ahead, but it kind of makes sense to me now. So the first block gets proposed in this L2 execute function, and all of these state transitions are just EVM actions, right? And so the first validator that sees that will re-execute it similar to any other L1 block, and then when they pass that on, they pass it on with a proof.
Exactly.
Okay, exactly. Cool.
Now there is a lot of moving parts. Like, what's Bob's motivation of generating proofs? Like, Bob should be really altruistic, or like if different execution clients adopt different proof systems, it may have different cost profile. Look, so how much gas are we charging here? So there is all this like moving parts, but like if we agree that like we can somehow figure those things out, like that's the idea, broad idea.
Cool, thank you.
But like there is still like some shaky things, like some very shady things going on. One is like, okay, I said Bob is going to generate a proof, like, and suppose Bob is altruistic enough to do that, like, but how fast can Bob generate it? In Ethereum, we have like 12-second slot time, like every 12 seconds we need to have a new block. And by the end of the 12 seconds, it should be clear if the validators like saw the block or not, and if they think the block is valid or not. So imagine an Ethereum block in which a few rollups invoked execute precompile. So at the end of the 12 seconds, it should be clear whether they think this block is valid, right? So somewhere in between in this 12-second, Bob needs to fetch the block, generate the proofs, and propagate the block with the proofs so that like enough number of validators see that and verify that. Bob should do it really fast. Like that's kind of not enough time for Bob. And like today, generating a proof for a block or a rollup batch, like for instance for scroll, it takes about like 5 to 20 minutes, and it's like the same for all ZK rollups. For some, it takes about 60 minutes or so, right? I think for ZK Sync, it takes 60 minutes. I'm not sure if it takes them 60 minutes to generate it, or for like cost efficiency, they do it with a delay. But what's for sure, it's nobody can do it in under 5 minutes. For rollup batches, it's like, and a rollup batch is a lot bigger than like a Ethereum block, right? It has a lot more room to spend gas. So it takes a long time, and it's much longer than 12 seconds. So something is not adding up. People are talking about the real-time proofs. Real-time proof is like the same time it takes to execute the block, in the same time you generate a proof. Maybe we even built like CPUs that generate a proof for whatever they execute, and like these crazy ideas. And it's definitely feasible, but it takes maybe 3 to 5 years to ship that. But we expect, like in a scroll, we expect to be able to generate proofs for like a rollup batch in like 10, 20 seconds in a year or so. And the other teams like Succinct and like Risk Zero and so on, they also talk about the similar numbers. It probably will be very costly and will be achieved through a lot of parallelization. So you need a cluster of GPUs to do it, but it would be feasible. The thing is, today that's not even possible. Like even if you have like 10,000 GPUs, that you can't do it faster than like a few minutes. But the hope is, with a reasonable number of GPUs, you could do it in 10 to 20 seconds in a year, right? So that's still more than 12 seconds. We need to buy some extra time for ourselves. And there is this EIP just doing that, called EIP 7862, that's titled Delayed Execution Layer State Root. So the idea of this EIP, for different reasons, like the motivation was not to accommodate native rollups. The motivation was something else, was to increase the throughput of Ethereum mainly. But people have already thought about this, and it's in the making. It's an active EIP. This EIP tries to propose something like this. It says each block n has a state root of this block, right? Which is basically I executed this block, and I got to the new state, the post state of Ethereum, and I committed to that into a state root. It's in the block header, right? So the state root of block n is in the block, and the post state of block n is in the block n, as it should be, right? This proposal, this EIP proposed that we do things with a little bit of delay. In the block n, we have a state root of block n minus 1. Like all the state roots are one slot delayed. So you execute everything with a little bit of delay. So the correctness of block n is not dependent on the correct execution of block n somehow. So when you are verifying block n, you just verify, okay, the transactions are well formed in this block, and the previous block is correctly executed. I have the commitment, something like that. Now, I don't want to go into the details. It creates a lot of complexity. Like you have to introduce a skip transaction. Somebody has to take on the risk of like transactions that can't pay for the fee, and like a lot of edge cases appear. But those are solvable and are in fact included in this EIP. And like suppose we can do that. Essentially, we are buying an extra slot time for ourselves that can be used for many things, and one of those things is generating proofs. So here, Bob can take like 12 seconds extra to generate these proofs, because like the people who want to verify that block have one extra slot to to spend. Go ahead.
Okay, we've got one from online here. It says, shouldn't every execution client then support every other supported proof system? Theoretically, if Geth came up with a proof system and proposed a proof with their block, Nethermind node also has to be able to verify it to approve the block, correct?
That's a very good question. The idea and the consensus currently is that's not necessarily the case. Like as I said, like for instance, today we have like sync modes that are available to only Geth clients, or sync modes that are only available to Nethermind clients, and they can do it only with their own peers of like the same client type. There are already optimizations built that only work with client types of like the same type, and the idea here is like there is not a lot of difference between one altruistic proof generator versus like 6 altruistic proof generator. If there is one person who does it for one client type, there are definitely 6 people who do it for other client types as well. Yeah, it's not maybe the most satisfying design in terms of like it doesn't look clean, but that's what's being discussed. And it's kind of necessary in order to get this prover diversity effect. Okay. But we are going to talk about like the things that could go wrong and would go wrong with this EIP. Why it's not so like straightforward. So the first thing is stemmed from this statelessness fact. And it would create a lot of inefficiency for data availability. Now let me talk about that. So we talk about stateless clients, and the fact that stateless clients need witness data or like these Merkle proofs added to the block so that they can verify the correct execution of the blocks or execute the block, right? And we need to go one step deeper. The way a state is structured in Ethereum clients is with like a data structure. Today, the data structure that the protocol uses is called Merkle-Patricia Trie, or MPT for short. MPT is just a data structure that's like stores a big chunk of data, commits to it, allows you to uncommit, some parts and stuff like that, right? If you think about the worst case possible for an Ethereum block, right? Not a rollup batch, which is a lot of blocks, just one Ethereum block. The worst case scenario for the size of the witness data is 300 megabytes. So today you could make a Ethereum block in theory that for a stateless client to verify it, it needs additional 300 megabyte data. Now, to put things in perspective, an Ethereum block cannot be more than 1 or 2 megabytes, like with all the blobs and everything, right? So 300 is a big overhead. And that's one of the reasons people are talking about vertical tries and like changing the state try of Ethereum. And like this is a EIP that has been talked about for a very long time as well. So there are other data structures that we could adopt that get the same job done as Merkle-Patricia try and improve the situation. So from 300 megabyte, we would go to 3 megabyte, right? But it's still a big overhead. Like for a 1-2 megabyte block, you get at least like 2 weeks, which is not that good. And if you think about it, these are numbers or overhead for like a single block. And a rollup batch, first of all, is executing a lot more stuff. So it's more than 1 block, expected to be more than 1 block. And a rollup batch is like always under 1 megabyte, and most of the time only 125 kilobyte. Like if you look at Optimism, Arbitrum, they submit the biggest, beefiest batches. And even for them, their batches are like up to 6 blobs. And 6 blob is like 750 kilobyte. Like, so if you compare these numbers intuitively, it should be immediately clear that doing things with this additional witness data creates a lot of inefficiency. And it comes from the fact that rollups today don't have to submit all these Merkle passes along the transaction data. They just submit the transaction data, right? But with the execute precompile, they need to submit that because like unlike rollup sequencers, Ethereum validators don't have the full state of every rollup, so they need that information to generate the proofs. There is no way to get around this. And the nice thing is, in order to make stateless clients for Ethereum better, we need to look into this problem. Already, this is a problem of interest. And this just creates another incentive to look into this problem more closely. So there is hope, but you could expect that it always remain a little bit at least inefficient, or maybe a lot inefficient comparing to the rollups that don't need to do this. Okay, so that's the first big problem. And it translates into more cost for users, obviously. And the second big problem is rollups are like proof systems of rollups prove rollups state transition function, right? And while rollups that are EVM compatible or EVM equivalent have state transition functions that are very close to EVM state transition function, they are not identical. And there are good reasons for that. For instance, all rollups should handle deposits into rollup and withdrawals from rollup. And that requires somehow modifying EVM. Like EVM logic doesn't have deposits and withdrawal. That doesn't mean in Ethereum, okay? It doesn't have any meaning in Ethereum. But like, for instance, in Arbitrum, you have new transaction type introduced just to handle deposits and withdrawals. And similarly in many other rollups such as a scroll. And you have like new functionalities and custom precompiles. And some rollups have certain functionalities and precompiles, and some have like different sets. Like every rollup is different from EVM, and they are different from EVM in different ways. So it's very hard to standardize something that covers all of them, or like borderline impossible, or maybe fundamentally at odds with like rollups being a playground for experimentation. So it's a very challenging situation. The idea is we need to make things a little bit flexible with the execute precompile. Now there are many ways to do it. I pitched a rudimentary way here, but like there are more interesting or like technically more interesting ways to do it. But like to just give you an idea, each rollup that like is using execute precompile it can feed in a list of opcodes or precompiles that it has introduced that are custom, and ask the execute precompile to just skip over them. Like in its re-execution, it just trusts the input data or the witness data as the result of those steps. Okay, I see a fancy precompile. I don't know what it is, but you tell me this is the result. Okay, I take it. Something like that, right? And there needs to be an additional proof system designed by that rollup that just proves those steps. So each state transition of the rollup is proved in two parts: the part that's EVM equivalent, and the part that's not EVM equivalent. And hopefully, the part that's not EVM equivalent is so small, it's easy to audit. Maybe you can even formally verify it. So it won't introduce all those security vulnerabilities back and make this whole thing useless. That's the hope. But there are nicer ways to do it as well. However, it's just not trivial. It gets ugly real soon if you start thinking about it. Okay. And before I wrap up, I wanted to talk about this based versus native as well. A name of native rollup has been overloaded. There was a famous talk in Bangkok titled Native Rollup something by one of the founders of Gnosis. And then they were talking about something different. This is not the native rollup they were talking about. They were talking about Ethereum building its own rollups and operating them and stuff like that, making them part of the protocol. This idea that we talked about here is kind of totally different. So that's something that you can get mixed up. And the other thing is based rollup that has been talked about a lot. Based rollups, based and native are orthogonal. You can have a rollup that's based but not native, is based and native, is not based but it's native, or all different combinations, right? Based rollups are about rollups that they don't have a sequencer. Whoever is L1 proposer is their sequencer at this slot as well. The L1 proposer, whoever is building the next Ethereum block, can propose the next block for the base rollup as well. A native rollup we talked about in this talk. There is an amazing opportunity to combine based and native and build something that is totally contained within Ethereum. You could build rollups without running any sequencer, without running any prover, without running almost any infra. And that sounds so powerful because as easy as building dApps, easy as deploying a smart contract, you can deploy a rollup suddenly. That's kind of a superpower. There are some problems like inefficiencies of native rollup and also inefficiencies of the based rollups. But both of them are being researched. It's one of the things that you could be very bullish about because it kind of commoditizes the technology of the rollup and also enables Ethereum core protocol to have a lot more influence and control over what's happening in rollups and how those rollups are coordinated and maybe interoperate. Just simply sharing the same proof system opens a lot of doors in interoperability landscape. Sharing the same sequencer also opens a lot of doors. And having them both, it's kind of like a superpower. But as I said, there are many open challenges to be figured out. And probably existing major rollups, it would be a lot harder for them to migrate to native or based. So I'm not predicting that all major rollups become native and based. That's probably never going to happen. None of the major rollups probably would be based or native. That's my prediction. But on the other hand, we would have many based and native rollups, and it would be almost trivial to launch them, hopefully, a few years from now. And that's it. Thanks for tuning in.
We got any questions? Any questions from anybody? No, nothing. Maybe one thing I'll ask is when we looked, I don't know if we talked too much or maybe I missed it on like how the economics are going to work around like based or native rollups. Well, I guess native in this case here. This week we look at what's happened with blobs, right? And we've kind of like, I use the term pretty loosely, like we've cannibalized Ethereum in this sense, right? So now it's like the great UX because it's like super cheap to use anything, but that like kind of hurts the economic security model as well. And like definitely, the demand and need for ETH is, you don't need as much anymore. So it's like also creates like, price problems as well. As soon as we introduce these, does that, what can that do to like help the health of Ethereum as far as like economic security, or what does that look like?
Right. Interesting question. So just to paraphrase Tangle, he's talking about, okay, we introduced rollups. Now gas consumption is as like lowest for like past several years. If you look at gas consumption, it was never this low. We were burning it. Now we are again in the inflationary like territory, like no more ultrasound money. This is not good. The value actual of Ethereum is like gone. I personally think the only play for Ethereum is to play for the future, that there are so many applications, so many rollups, so much DA usage that like even with the low price per unit, it would generate a lot of value. So I mean, it's kind of like fighting for the market share. At this stage, Ethereum is practically fighting for the market share. It's trying to enshrine entrench itself into like all applications that have a need for DA. And then hopefully more and more applications that are DA hungry are built on Ethereum. And then like nobody cares that a single blob is cheap. There are like millions and millions blobs consumed daily, and then we have again value accrual for Ethereum. So I guess it's kind of a defendable path and hopefully pans out. Also, there is always the opportunity to tune in the pricing. So I think there are proposal. There is this one EIP by Max Resnick that talks about increasing the base price of every blob so that the price discovery of blobs kick in faster, and like we don't sell blobs for cheap ever, something like that. So there are active discussions around this. However, this based and native, I think, could be helpful as well. One reason like based rollups are helpful is like based rollups put Ethereum nodes in charge of, sequencing rollups. That means they are in charge of collecting the fees for rollups and also collecting MEV for rollups. That kind of internalizes the value of the transactions and MEV of the rollups back into Ethereum. So it creates more opportunity for Ethereum to capture rollup value. So that's obviously good for the problem you mentioned. The other thing is with native rollups, it would become like easier to launch rollups and maintain rollups. So it would help with the idea I just talked about, that like we could have many rollups, and even though each unit of blob is cheap, like there are many units of blobs being purchased. So
yeah, I get that point too, because like the idea was, okay, we can put, we used to have a bunch of vehicles that were really large and inefficient and, really poor like gas mileage, let's call it. And so to put fuel in them, you needed a lot of fuel to get anywhere. Now we've just like flooded the market with like extremely, efficient vehicles that are highly performant and efficient. And now like the demand for fuel has gone down tremendously. Like that's kind of how I think about it. So it's like, oh, now we can have more and more drivers on the road and more people, more participants. Exactly. However, what happens when like that is always going to be a race to zero, because somebody's going to figure out another way to make it even faster and cheaper and faster and cheaper, or we continue to push out saying like, well, okay, L2s are starting to reach a certain price, where now we're back up to, we're paying 5 cents a transaction now. that's like too much. So how do we then keep going further? And how do we go out to, and now we're L2, L3, L4, L5, you know, where eventually we just like, we keep pushing that out. So what can we do that, like, I guess I'm thinking about this as kind of like this, you know, maybe with like what you were describing on based and native rollups, like where we can actually do something that gives back and like you bring that back to Ethereum, but making that both beneficial for both parties, right? Because if we were to look at something like why would Coinbase want to give up 90% of the profits, even if they aren't quote unquote dumping them, or so they say they aren't, but like if they're like, oh, we're Ethereum aligned and we're hanging on to the ETH and we're not, we don't know what you're doing with it. But like the fact that the value is going over there to another, you know, to an L2, instead of that going back to like the protocol or going anywhere else other than, you know, basically into their pockets, like that kind of sucks. Like great, they're providing an awesome service, but like they're killing it as a business. They are killing it. So how do we like build, you know, put some guardrails in place so that it goes back to the protocol and that it benefits everybody instead of just like one company? I guess that's kind of a cherry picked, you know, example, but
So I guess like there are two parts in my mind about what we discussed. There is like this Jevons paradox. I'm not sure if I'm pronouncing it correctly. It's basically what you just described. There is like demand for a resource, and like we create more efficient ways of consuming that resource, but that ultimately creates more demand for that resource instead of like reducing the demand for that resource. Like recently, Microsoft CEO tweeted something about this paradox in the context of AI, in the sense that like, maybe we make like use of AI more efficient, but that's not going to, that's not going to like make GPUs like useless resource or like less demand for GPUs. When you make AI more efficient, it requires less GPU, you will use it in more places, so ultimately you may end up needing more GPUs, something like that. And this is true for like the gas and cars and Ethereum transactions and whatever. But like putting that angle aside, focusing on like the fact that the roll-up companies make a lot of money and that value is not captured by Ethereum, and it kind of looks like wrong. Kind of looks like Ethereum is subsidizing roll-ups the way US is subsidizing Canada. I actually think it's very similar to how Donald Trump claims that US is subsidizing Canada, because like they are paying Ethereum and they are, I would claim, attracting net new users. Like if it wasn't for rollups, we wouldn't have this many users. And like even if you think about it a bit more deeply, if it wasn't for rollups, we probably didn't have like proof systems and all this ZK tech and like optimistic proofs and so on. So I think generally what Ethereum did, like the strategy was definitely correct, even in hindsight. Because like we magically found a way to convince VCs to fund something that's useful for everybody and may never give them anything back in return, like if they have not dumped already. But so I mean, there is always an opportunity for us to pivot and like take all those technologies and like snarkify Ethereum and do all cool things on Ethereum. But whether we should do it or not, I think there is a lot of demand in the community to build like kind of like Ethereum native based rollups. However, it would take like years with the pace that like Ethereum core development happens. So I don't expect it to arrive anytime sooner than like 3 years from now, but it will probably arrive sometime. And before that, I don't think we can force like Base or like any other rollups to do more than like what they are doing, like be more aligned than what they are. Like any idea about taxation or like something of that sort either requires massive like social coordination and social pressure, or requires Ethereum to somehow kind of in the bad face breaking the social contract with the rollups. Like, I thought about this problem a lot, but I also am a big ETH believer. Like I work for a roll-up company, Scroll, and we benefit from this situation. But I also hold a lot of ETH. So to be honest, I think in the long run, it's best for Ethereum to stay friendly to the rollups and not think about the short term, not think about the value accrual in the short term. If you think about it, even the whole like revenue of the base, which is like off the chart comparing to all other rollups, if you take that and like distribute it to Ethereum like holders, it's peanuts. It's nothing, right? And the game we are playing is mostly like Ethereum moneyness, Ethereum like network effect, Ethereum mindshare, Ethereum adoption. Those things are far more valuable to Ethereum. And like if Coinbase takes Ethereum and evangelize it and make a lot of money, I'm happy. At least for now. Maybe a few years from now we should change our strategy. Maybe some of these rollups try to become L1s or like I don't know, do other things. But for now, I think we should be happy and we should focus on like making everything more efficient for rollups rather than worrying about them cannibalizing Ethereum. Yeah.
When you're talking about economic security or stability, do you like expect that Ethereum's value should always go up, or isn't it enough just to remain valuable enough to motivate the nodes to continue operating?
Yeah, good question. I think there is this fundamental relation between the price and economic security that's obvious. Like if the price goes down, like or too low, things are going to break. Like this is obvious. And if the price doesn't go up, you don't add to economic security, so you keep the economic security or the secure economic throughput limited. So it's always good for the price to go up because you can do more things securely on Ethereum, right? Like kind of at least like theoretically. But to be honest, I think most of the time when we are talking about this like notion of economic security, we are mostly upset that the price is like not higher, which I like I'm empathetic to. But in theory, it could affect economic security, and it's always better to have higher price, right? So that we can do more things securely on Ethereum, like in theory. Like suppose we have a new stablecoin or like Tether or USDT means like $100 trillion on Ethereum today, and central banks start sending money on Ethereum for like trillions of dollars or whatever, then it becomes suddenly profitable to exploit Ethereum. Like we need more economic security, like something like that.
Yeah, and then otherwise you just end up with like the validators or the people that are backing it, and it's like the same concept goes with Bitcoin and miners, right? As soon as the price is like no longer profitable to mine it, it's like I have to do this out of the goodness of my heart. If I'm a business and a corporation running this operation and I'm like running at a loss and doing so, like you can plan that into your business plan if you are able to, but at a certain point it's just like it's no longer profitable to run it, therefore there's less security. So then that just keeps going down and down and down, and if we end up into a death spiral, that's, eventually it's like, well, there's no more security because there's no more price, and then it just like continues going downwards until you get to an area where it's now vulnerable and attackable. Canada, is that what you just said? Oh, Canto. Yeah.
I think, and maybe correct me if I'm wrong, I think in theory, because operating an Ethereum node is so low resource, and you can put thousands of validators on the same piece of hardware, that the cost to run an Ethereum validator as like an institution, like so long as they have like they would have to their cost would be similar for the same number of validators, because it could be reusable across their validators. So it's like whether you run one or multiple or whatever, and like it wouldn't be like I don't know. I think it would be like ETH would have to be super, super, super low to justify them not being able to pay for that operation, if I'm correct. Because also the whole model was designed back when ETH was like sub $100, right? Like they were like assuming like even that was sufficient for like the network operations and their calculations. Then it like the price exploded so far beyond from when they first designed that system. So anyway, that's
yeah. I mean, I agree. I don't think if Ethereum goes to like $100 tomorrow, suddenly we have a problem with economic security. I'm not worried about that. But on the other hand, I think in theory, the idea that price influences economic security is correct. However, practically it's not of relevance, maybe, at least not in the price range we are operating in currently.
Agree.
Yeah.
Do you think L2s are Ethereum aligned if they dump their validator fees?
Good question.
They don't have validators.
You know, their proposer, sequencer, same
Yeah.
same thing. Their computer fees.
It's not the same.
It's a computer. It doesn't matter.
Yeah, I get the idea.
They're centralized server fees.
Yeah, Ethereum aligned. I don't know, Ethereum alignedness means different things to different people. Many of the rollups, they are essentially Ethereum. They don't have like Starknet has Cairo, right? And I don't know, Arbitrum has a stylus, and maybe Aztec has Noir, but all of them support EVM and EVM smart contracts and Solidity. And when they go onboard new developers, they are evangelizing Ethereum, they are evangelizing Solidity, they are onboarding them to this Ethereum universe tech stack. And even if you think about, even if they don't build any cool technology like Snarks, Plunky 3, I don't know, ZK EVM or whatever, even you don't consider that. Even if you don't consider the fact that they bring new users, net new users, because they're cheaper and so on. The fact that they are onboarding more developers to the space, and they're actively doing it, running hackathons and so on, they're contributing so much value to Ethereum. They are basically the BD for the rollup teams are BD for Ethereum. And that if they spend some ETH to pay their expenses, I wouldn't be mad as a ETH holder, right? So to summarize, I would love them not to spend their ETH. Maybe.
Do you think rollups should have charged gas in USDC, and in that case they would have to buy ETH to pay for their validation, and then they don't actually have to dump ETH?
If I could jump in, I think that at the time, the intention was to create demand for ETH and to be ETH aligned, because the notion was that we are Ethereum, so we use ETH for fees, just like Ethereum, which is a demand driver for ETH on mainnet, right? I guess, I don't know. I'm not sure exactly what people were thinking at the time of designing that system, but that is what I believed the intention to be. And perhaps the consequence of them then selling their ETH, if they had to for operation costs, might have been under thought out potentially, but I don't think it was ever designed to be something that would rob Ethereum. I think that the intention of the design was always to create demand for Ethereum in some way, and then also pay Ethereum for DA. And I also like what Mohammed was saying about in the far future, it could be a crazy different state in that there's millions of blobs, and they might be really, really cheap, but then it just allows for so much activity and seamless native composability on top, with the things like native rollups and whatever. It's just creating a whole new economy that we can't even imagine today, in our normal world of just how blockchains can operate. But sorry, I'm kind of going off a little bit, but yeah.
Yeah, back to the original question, I feel if you ask users to pay USDC and then go buy ETH with that, you're just shifting the demand for ETH, because the user who's paying ETH at some point acquired ETH as well, right? So it shouldn't be fundamentally different whether you buy ETH with the fee that was non-ETH, maybe a stables, or get ETH directly and sell excess of it. It should relatively be the same. Maybe inducing demand.
If you look at
different times.
Base, for example, I don't know the exact numbers, but I'm making it up. They pay 8 million in blob fees and dump 80 million. So it's not like, yeah, that they're dumping more than what they're actually paying in fees to mainnet.
Yeah, I
is the
think
main
they
point.
claim that they are not dumping and they just custody of chain. So,
Sure. Yeah.
But assuming that
they're
they're dumping.
redistributing to, diversify the holders.
Yeah. Assuming that they are dumping, like even in your proposed design, if they were just charging USDC directly, and they would buy 8 million ETH to pay for the fees and so on, and like just keep the rest as USDC and not selling. What I'm trying to claim is it should be economically net equal with the case that users go buy ETH maybe a little bit earlier and then give it to them and like they sell, because like users didn't have to buy that ETH if it was not required of them to pay ETH. And in fact, I think the fact that they accept ETH and only ETH as fee is a very positive thing for ETH, because it contributes to the moneyness of ETH. Like why US dollar is valuable? Because you can buy anything with US dollars. Like everything is priced in US dollars. And like that contributes to the moneyness of it. But like I'm not an economist and I don't know anything about anything.
So I would like, I see what you're saying with the like on the balancing side of like balancing the budget as far as like the ETH used and the ETH spent and all that. But we do end up into Julian's point where we are creating sell pressure, if that is what the roll-up is doing. If they're taking that ETH and then saying, hey, we're not going to disclose, we're just sending to an exchange. Whenever I see something hit the exchange, I assume that that's a sell, right? So like if we didn't have that, if that was USDC instead, that prevents that sell pressure, that is whether it's on order books, whether it's on whatever it is, right? So
you're unhappy with the sudden sell of a large amounts, because like otherwise users who paid that fee, like if we were charging USDC, they didn't have to acquire ETH at any point. Like
yeah, good point. And this is where I'm just saying that if we look at the amount of ETH that is needed for like in this example here, it was like 8 million versus 80 million, right? So the 80 million in ETH that came across, I guess, or that they would be making in fees, that could have just stayed, I guess, you're saying that was all ETH at one point. Somebody had to have bought ETH.
Right. I mean,
see. Okay.
Unless in your model, the price, like the market impact is higher if you do like large batches, which is kind of a reasonable assumption, because then you trigger liquidation and so on and so forth. I don't know, like maybe it's a reasonable thing to assume, but like on the other hand, the contribution to the moneyness of it is like not trivially like calculated for here. Like it's not obvious to me how much is the value of like everybody accepting ETH as money. That's for sure is nice.
Okay.
Yeah.
Anything else? We get one from online here, from our birthday boy again. If we have both native and based capability, then what is the piece of the puzzle left to do by the rollup? Doesn't it mean that Ethereum can scale itself by adding another rollup every time it needs to scale more? I think we were talking about that earlier to the, what was it, Judah or Juxta Paradox? Who was it? Jebediah? Yeah, anyways, the wiki page that you had up, I can't remember what that was. Yeah. Javan.
Let me pull it up.
Jebediah?
I'm not sure. Javon's Paradox.
Yeah, there we go.
Yeah.
So anyway, I think that's what we kind of touched on it. I don't know if there's anything more to go on that. But.
Yeah, I mean, just to summarize once again, I think if we have based and native tomorrow, that's a very big unlock, and like many dApps would like go immediately into rollup mode, and it would be beneficial for them. However, there is still need for like other entities. Like based rollups are notoriously slow, in the sense that you have to wait 12 seconds for your transaction to be confirmed. And like that's a long time for rollups, because like Arbitrum does it in 300 milliseconds. So we need faster pre-confirmation. So there probably are going to be off-chain entities, or like maybe in the very far future enshrined entities doing pre-comps for these rollups. And like there is also like this DA efficiencies and other things I talked about for the native rollup case. So maybe we could introduce like some entities that would reduce this cost. And on top of that, there is also like a need for entities that facilitates interrupts somehow maybe. maybe solvers and like intent networks and so on. So even if we have based and native, there is probably room for rollup operators or like rollup infra companies to do some stuff, such as precoms and interop and so on and so forth. But like, it's just speculation at this point. It's for sure going to be amazing, but I'm not sure exactly how. Yeah.
All right, awesome. Any others? Any more questions? Going once, going twice. All right. Well, yeah, thank you again, Mohammed. Okay. I guess if nothing else here, feel free to stick around here for a little bit. Fold up your chairs, and we'll, like I say, next week, maybe we're going to do a little field trip over to Funk Cafe and listen to Ken Sim speak. So, okay. Thanks, everybody. All right. Bye-bye.